Hi, I'm Ajinka from Gridmo. In this video, I'll be showing you how to use Gridmo to merge multiple PSS E plant models into a network model. First, I'll be giving some background behind how and why we merge projects into network models. Then, I'll be using a Gridmo example to demonstrate how to use Gridmo to merge two projects into a sample network case. And finally, I'll explain how Gridmo users can expand on this example to prepare their own network models for typical network studies. Let's get started. Network models are snapshots of real-world operating conditions typically created in PSS E and maintained by utilities. Generally, these models only model the present-day behavior of the network, meaning they do not include any future augmentations such as committed generation or network augmentations. So, to study the future behavior of the network, proponents often need to integrate these augmentations into their network models. So how do we go about doing this? Let's take a look at a simplified example. Here we have a simplified network with a number of generators, including a coal power station, a solar farm, a hydro power station, a battery, and a gas-fired power plant. We want to add our solar farm project to this network with a dispatch of 10 megawatts. To do this, we will need to ensure we are still maintaining the balance between load and generation in the network. This is to make sure our network still represents the scenario we wish to study, including the same load demand, total generation, and power flows across major interconnectors. Also, one assumption we will make is that there will be negligible load growth between the present day and the future scenario we are modeling, which is just 1 year into the future. Given that we won't be looking to adjust the load demand, let's adjust the generation in the network instead. Looking at our network, there are a few generators we could pick for reducing their generation. So how do we decide? There are a number of factors we could consider when adjusting the dispatch. For example, we could consider dialing down generators which are planned for decommissioning in our future scenario, or we could dial down generators which are exceeding local constraints and are candidates for curtailment. We could also consider the location of the generators, as we ideally want to dial down the ones which are roughly in the same region as our project. Finally, the factor which is most commonly considered is the price of the generation which is provided by these generators. Given our simplified network operates under a market dispatch mechanism, we will look to displace the most expensive generator in this network. For example, here are the prices of the generators in our simplified network. In this case, the gas-fired power plant is the most expensive, followed closely by the battery, then the hydro power station, then coal, and finally solar. Now, based on this, we can assume that the cheaper generation provided by the solar farm will displace the most expensive generation. In this case, the gas-fired power plant. So we can go ahead and dial down the gas-fired power plant by 10 megawatts to balance out the generation provided by our project. Let's now look at an actual example to see how we can do this process using Gridmo. So here we are in the Gridmo web app, and I've just opened up one of the examples from the Gridmo examples library. You can do this by going to the menu icon, selecting examples, and then selecting the how to merge multiple PSS E plant models into a network model example, and just select upload. So in this Gridmo run, we can see there are two PSS E static nodes, one for each of the projects that we're going to merge into our network model. And then we have a PSS E dynamic node where we'll just be performing a flat run of the updated network model with our two projects. So before we dive in, let's take a look at a diagram of the network to see how we're going to merge these models. In this network SLD, we can see that we will be merging project 1 into bus 66001 with a dispatch of 20 megawatts. And then we'll be merging project 2 at bus 6606 with a dispatch of 10 megawatts. Then, to balance out the generation in the network, we'll be reducing the dispatch of generator at bus 1401 by the same amounts. Let's now take a closer look at the example to see how the merging is done, starting with the first PSS E static node. So in the Select Model tab, we can see that we have specified the location of the first project that we are merging, which is a 40 megawatt solar farm. Then, in the Define Simulation and Outputs tab, we have enabled the merge into network feature. This allows us to specify the location of the network model, which we will be merging our project into. So in this case, this is just a gridmo example network. Then we have specified the bus number in the model where we will be connecting our SMIB to the network. So in this case, that's bus 19994. And then the equivalent bus number in the network, which is bus 66001. Gridmo will then add a zero impedance line between these two buses when doing the merging. Now that we've told Gridmo which project to merge and where to merge it, we need to set the dispatch of the merge project. Given that our sample network model represents a winter scenario, we are going to dispatch our new project at 50% capacity or 20 megawatts. So this is done via this control command here. Then, noting that our project normally operates in voltage droop control mode with a default voltage of 1 per unit, we're going to use this control command to set the queue dispatch. Then finally, we will dial down the marginal generator at bus 1401 by 20 megawatts, which will mean reducing the dispatch from 44 megawatts to 24 megawatts. Now for our second project, we will follow the same process, except noting that this project normally operates in reactive power control mode with a default set point of 0 megavar. We have dispatched this project at 10 megawatts and reduced the marginal generator by the same amount, down from 24 megawatts to 14 megawatts. Also note that we need to enable the use model from the linked PSS E static node option, as we'll be using the SAV case from the previous node which merged the first project. Finally, there is one additional step we will take after merging the second project. Given that this is the last project we're adding in our network, we will redispatch all of the previously merged projects as well, or in this case, just project 1. This is because after merging the second project, the load flow would have changed, which would have slightly affected project 1's dispatch from the previous node. Note that the more projects you merge, the more inaccurate their dispatch will be from the PSS E static node, which dispatched them initially. So it is always good practice to redispatch all of the previously merged generators in your last PSS E static node. One last thing to do in the PSS E static node is to tell Gridmo to output the updated network model with the new projects. You can do this in the Advanced tab by adding the Advanced parameter for outputting the converge case and specifying a name for the SAV case as well. Now moving on to the PSS E dynamic node, we have added the location of the folder which contains all of the necessary DYRs to run the model, including the ones for our project. We can do the same for the DLLs in the field below, but in this case, our example doesn't require any additional DLLs, which is why this is empty. In the Define Simulation tab, we have set the simulation time to 20 seconds and no other actions, which means we will get a flat run. Finally, in the plot node, we have set up our subplots to give us the voltage, active power and reactive power for both of our projects, and the voltage and frequency at different network buses. Let's now launch the simulation and have a look at the results. Here we are in the outputs folder for this simulation. We can see that there is a model outputs folder which will contain the updated network model with our merged projects. So you can see here we have a SAV case called converge case, thanks to the advanced parameter that we added earlier. Then if we go back and have a look at our plots, example 4, flat run, we can see now that we have added projects 1 and 2 with the dispatch that we asked for earlier. So project 1 at 20 megawatts and project 2 at 10 megawatts. Now that we've looked at this gridmo example, let's look at how you can expand on this further to build your network models. So starting with this run, you can easily duplicate the PSS E static nodes to merge more projects. So for example, here we have a run consisting of 6 PSS E static nodes, merging 6 projects, and you can even add dynamic nodes in between to ensure that your updated model is stable after merging each project. Once you're happy with the updated network model, you can extract the updated network model in the last PSS E static node using the advanced parameter that we discussed earlier. This sav case can now be copied to your inputs folder to be used with other gridmo templates. Thanks for watching.